we've got this. So we were working with a lot of inequalities yesterday where we just had one inequality sign. Sometimes we're going to get these where they're kind of sandwiched in between. And you can either split these apart and solve them independently, where you do like 3 is greater than 4x minus 2 and 4x minus 2 is greater than negative 5, and do it as 2 separate pieces. That's totally fine. A lot of times when they're in this kind of triple situation, I just leave them where it is and work from the middle outwards because it's sometimes easier. So when we're looking at something like this and we're trying to get our x by itself, what am I going to need to do to this chunk to get my x by itself? Add 2. So then if I need to add 2 here, I also need to add 2 here. Because we have 2 inequality signs, I have to hit all 3 pieces. So watch out for the fact that I have 2 inequality signs here. You can do this in one chunk like this, or you can split it up into 2 inequalities and solve each one individually. You should get the same answer. But then we're going to have that 5 is greater than 4x, which is greater than negative 3. And again, what am I going to do to my x to get it by itself? Divide by 4. So if I divide this by 4, I need to divide this by 4, and I need to divide this by 4. So our middle is going to have just our x. We're going to have our 5/4, or 1.25, and our negative 3/4, or negative 0.75. Again, I genuinely do not care if we have fractions or decimals, as long as we haven't changed the answer. Quarters, we can definitely do as decimals. But we need to write this as an interval. And we always do our intervals from smallest to biggest. So which of these numbers is smallest? The negative 3/4. Am I going to use a parentheses or a bracket on that one? Parentheses. And so our answers are going to go from our negative 3/4 all the way up to 5/4. If this is a tricky thing for us to spot, feel free to sketch it on the number line, because I know at our 5/4 we'll have an open circle, zeros in the middle, and then we'd have our negative 3/4 over here. So if we put them on the number line, it's in between these 2 pieces. So we're always going to set them in our intervals up smallest to largest. Smallest on the left, largest on the right, just like it's a number line. So if you need to, or if you want to, or if it helps you, draw it out. Totally fine. I have them drawn out in my notes. No shame in using coloring. Coloring is awesome. So very similar vibe on our next one, where we have this fraction thing. We also have mixed inequality signs. We need to be careful of that. We've got 3 less than or equal to 2x minus 9 all over 5, which is less than 7. Again, if you don't like doing this as a trio, you can split it into 2 pieces. I'll write it out for you, but I'm going to solve it as a trio. You could solve our 3 less than or equal to 2x minus 9 over 5 and 2x minus 9 over 5 is less than 7. You don't have to solve them like this, but if you hate the triple, do this and just smush together for your answer. I think it's less work to work like this because it works all of them at the same time. So I prefer to do that, but totally up to you. I'm just going to move these guys out of the way. So you can totally work with these and you'll get the exact same answers, but I think it's easier to just work from these guys. So making sure you're paying attention to the fact that I have 2 inequalities here. What is the first thing I need to do inside to get my x by itself? Times 5. We're going to times by, ooh, wrong color. Ah, yep. Times by 5, times by 5, times by 5. Everybody. My denominator cancels out. We're going to have 15 less than or equal to our 2x minus 9, which is less than 35. Then what are we going to do? Add 9. Add 9. Add 9. So that's going to give us a 24 is less than or equal to our 2x, which is less than 44. And we're almost there. Because what's our last step going to be? Divide by 2. Those are the exact same steps you would take for solving both of these. You would just do them independently, and we would get to the exact same answers, where we're going to have a 12 that is less than or equal to x, which is less than 22. And when we have it this way, where we have our smaller number on the left and our larger number on the right, it's a lot easier to drop it just directly into its interval notation than when we have them swapped like on the last one. Because our smallest number is our 12. Our bigger number is that 22. Is the 12 going to get a parentheses or a bracket?
Bracket.
Bracket. And is the 22 going to get a parentheses or a bracket? Parentheses. Ta-da! Whoop. Okay. Sometimes we get fractions and they're a little icky. Or at least they're icky feeling. So looking at this left one, we've got 4 over 3x minus 5 is going to be less than 0. If it is less than 0, is this side going to be positive or is this side going to be negative? Negative. So we know, because it's less than 0, that this whole fraction needs to be negative. So the information that we have here, I have 4 over something. So my denominator is going to need to be negative, right? Because if my top is positive 4, the only way I'm getting a negative number is if that denominator is negative. So we want to know when our denominator, 3x minus 5, is negative. When is that less than 0? We don't need to solve it as a fraction. I just need to know when it's negative. So we need to know when this guy is less than 0. That will make my whole fraction negative, which will make this true. So we don't have to solve it when it's as the fraction here, because that's gross. We can just solve this. So what are we going to do to solve this? Add 5. So we're going to have our 3x is less than 5. Because the 4 is already positive and we're trying to make this fraction negative, the 4 is irrelevant. It doesn't matter if that's 4 or 20 or 843.2. As long as that denominator is negative, my whole fraction is going to be less than 0. Yes, dear? Yes. So if your numerator was negative and I needed this to still be less than 0, then the denominator would have to be positive. Because if my denominator was negative and my numerator was negative, now I'm greater than 0. Now it's positive. So when we have these ones with the fractions, it's pretty much always going to be set with a 0. Whether it's either less than, so it's negative, or it's greater than, so it's positive. So in this case, we have that our x is going to be less than 5/3. So our interval, if x is less than 5/3, is going to go from negative infinity up to 5/3. It's still going to be an interval. It's anything from 5/3 and down. And you can test a value if you want to. You could put in a number smaller than 5/3. You could put in 0. You're going to get a negative value. You could put in 4/3. You're going to get a negative value. You can put in negative 800. You're going to get a negative value. You don't have to, but you can. So very similarly on the right one, we are going to look and see when is this fraction going to be greater than or equal to 0. So I already have a positive 2 in my numerator. So if I need this to be greater than or equal to 0, my denominator x minus 7, oh, that's a 7, needs to be greater than or equal to 0. But can I equal 0 in a denominator? No. If I had the denominator set equal to 0, it's undefined. It's no longer actually a function. So even if it is equals to, we're still going to have a greater than because I can't divide by 0. So they're just trying to trick us with those. The book likes to try and play tricky games like that, which is why we talk about it. Because on this one, our x is going to be greater than what? 7. So our denominator has to be positive to keep our fraction positive, and our denominator can't actually equal 0. If I put x is 7, I put 2 over 0, I get undefined. It's not 0. My numerator can be 0, but my numerator is 2, so irrelevant. Our interval here is going to go from 7 to infinity. I'm not going to be super petty about this part, but I just wanted to talk through it because technically it cannot equal 7 because our denominator would then be 0. Okay. The only other part of 2/6 is absolute values. So when we have problems like this, it basically makes problems like the trios. So whenever we're working with absolute values, just like when we were solving them in Algebra 2, where we had to get our absolute value by itself first, that still remains true. We need the absolute value by itself before I can take it out of the absolute value bars. But remember that absolute values are talking about the distance, how far away from 0 it is. So if I think about the absolute value of x being less than 3, if we think about that on a number line here, if 0's in the middle, I know I can take anything from 3 and smaller down to 0. These all have an absolute value of less than 3. But I can't just keep going forever because I would need to stop where? -3. It would need to be between +3 and -3. So whenever we have these absolute values, it's going to turn itself into one of those trios. Because my x really needs to be less than 3 or greater than -3. As long as I have a value between those two, my absolute value is less than 3. So the absolute values just turn into our linear functions. And this one's interval is just going to be the -3 to +3. It's the very same on stuff like this. If my distance is less than 4, that means I need to be between 4 and -4. So we're going to have our -4, which is less than this whole argument in here, my 2x plus 5, and that's going to be less than our 4. It's stuck in between. So if we have our absolute value that is less than, it's going to be stuck in between. This is stuff we can solve. If we have an absolute value that is greater than, I'm just going to talk it through for a second because we are like a minute from the bell. If we have an absolute value that's greater than, we're going to set it up as 2 separate ones. We'll do a couple like that on Monday because it's, or Tuesday, that's what I meant, because that'll be 2 separate intervals. So this one we can solve. We can get it all the way down to an answer. It's going to be fractiony, but we can do it. So I encourage you to try the ones that are greater thans to face outwards. We'll talk through one of them real quick on Tuesday when we come in. But then we only will have one section left to go before our test. I do have the chapter reviews out. I know the pile is significantly smaller, so I think they spotted that. But I have here the chapter reviews. This is for the whole chapter, so it includes the stuff which I'm going to talk about on Tuesday/Wednesday. Okay? So if there's things in there that we go, oh, what's that? It's what we haven't talked about yet. Okay, you don't have to take it, but since it was a long weekend, I know some of us went to work on that beforehand while we have time, so I have it available. If you don't want to pick it up right now, you don't have to. Your choice.